Well, it has been a long time between drinks, hasn't it? And for that, I apologise. To give you the TLDR, I basically didn't have enough mental capacity for podcasting in the latter half of last year. A family illness hit very close to home, and I'm only now finding the space to get back into it. Anyway, let's talk about this episode's guest, shall we? Dr. Manreena Kaur is a National Health and Medical Research Council Early Career Fellow at the Therapeutic Brain Stimulation Division at Monash University. She began her career in medical science dealing with youth mental illness and has since moved to the area of therapeutic brain stimulation, hoping to find new methods to treat depression, anxiety and psychotic disorders. Let's start by finding out what put her on that path.
I think as long as I can remember, I've always had a very scientifically inquisitive mind, and I was always really interested in how the world works and the universe works, but more than anything, how living things worked. So humans predominantly, and plants and animals as well. So biology was my favorite subject at school, and as I grew older, I started becoming more interested in how we thought, and how I found it really interesting that to think about how our thoughts interacted with our environment, and how our environment could impact on how we felt and how we thought. So I started becoming very interested in psychology. And I was actually part of a group of students in high school that tried to get the school to put psychology on as a subject. It didn't quite work. So I just went out and bought some psychology textbooks and started looking into it myself. I guess in that sense I ended up doing biomedical science, which was very fitting. And it is actually really fitting that I ended up being an academic, because I really enjoyed English and drama and more creative subjects and writing in school. So I can't really think of anything that would fit me better now. So at school I did biomedical, at university I did biomedical science, and I really enjoyed it theoretically. It was focused on the body in disease, basically. And I particularly liked the neuroscience subjects and psychiatry subjects, but I really, really hated doing the practicals. So they were like 10 hours of practicals sometimes, between 6 and 10 hours of pipetting things, and I just did not find that enjoyable at all.
So not the most exciting?
It was just boring. It was just downright boring, and I think I realized that I'm too much of a people person to be stuck in a lab. And so I was really lucky then to get a psychology research project after during the final part of my undergraduate. And I learned how to use a technique called EEG, or electroencephalography. So that's basically recording the electrical brain signals on the scalp. And that basically shows us, we can interpret from those how we process different things in our environment, such as sounds or what we see. And the project was just looking, getting healthy people in, doing an EEG on them, and looking at how the brain processes certain sounds. And I really, really enjoyed that. Initially, I thought, this is a bit of a wishy-washy sort of subject, processing sounds. And I, wanted to learn about cancer or immunology. But I realized it was actually, that was my saving grace, I think. It's what got me into clinical research, working with people in neuroscience. So after that, I looked for a research assistant job in clinical research, and I started working on youth mental health. So that was the beginning of my postgraduate career.
So how did you go from researching youth mental illness to brain stimulation?
Oh yeah, that's a bit of a jump, I guess. It keeps narrowing down the further you go. Your specialty just keeps narrowing. So from youth mental illness, so I was looking at the changes in the brain that occur during youth mental illness. I specifically focused on depression, bipolar disorder, as well as psychosis, so like schizophrenia. In my postdoc, so after my PhD, we started a project looking at the most popular form of brain stimulation, non-invasive brain stimulation anyway. It's called transcranial magnetic stimulation. So that's an established treatment for depression, quite well established actually. So we started
Sorry.
Yeah, sorry.
Just before we go on, what exactly is transcranial magnetic stimulation?
It's essentially applying a magnetic field to an area of the brain on the scalp, so it's completely non-invasive. And by doing so, you induce a weak electrical current. So that basically stimulates the brain cells in that area of the brain that you're targeting in a particular way. And that is therapeutic for many disorders, but it's approved for depression, TGA and FDA approved for depression. So that's, and it's actually really surprising that a lot of people, well, it's not surprising, but it's unbelievable that it's not really heard of, and really that's just because it's not accessible to the public. It is very expensive. It requires almost daily treatments at a clinic over a few weeks, and it's not available everywhere because it's expensive. So we are trying really hard as a brain stimulation community to get Medicare to support it as a treatment, and also to find other ways to make it more accessible, to reduce the time it takes to deliver treatments and the number of sessions you have to go through.
Do you think that brain stimulation suffers from, say, a stigma from previous treatments like electroshock therapy?
Yeah, look, I think within the scientific community, I think that there's not much of a stigma, but I do think there is there is some of that still remains. And I noticed that recently when I was at a student night talking to potential students, and students that hadn't studied neuroscience or psychology were quite alarmed by it. And it's just that we just haven't. It's just awareness. It's actually, and I think a lot of the stigma comes from One Flew Over the Cuckoo's Nest days of ECT, and that really isn't what it's like. ECT isn't what it's like anymore at all. So I think in some senses, but I don't feel like we. I don't recognize that there's a stigma when we're speaking to patients. In fact, that they're quite understanding and are on board with it.
So, what are you working on at the moment?
So essentially, my focus now is to bring together my previous experience in youth mental illness with my current experience that I'm developing in brain stimulation. So it's something that we haven't really done very much research on as a community, a research community. And I think that's because, brain stimulation has been quite new, and now we're moving into, rather than treating people that don't get treated with anything else so people that are treatment resistant, starting to think about brain stimulation as a first-line treatment. So I'm basically utilizing brain stimulation now in my current and future projects to treat youth mental illness. And basically, at early stages of illness, we find that people respond better to almost any treatment because your illness is less chronic. From a neurobiological perspective, there's less damage in your brain. And so it just tends to respond to... you tend to respond better to a lot of things. So we haven't really tested this yet. So that's something I'm really hoping to do in depression as well as psychosis.
As your career in brain stimulation has grown, what are the lessons that you've learned both as a researcher and as a woman in this sector?
Yeah, so I think joining my current group has really opened my eyes to a range of gender inequality issues in STEM. And I'm very fortunate that I'm part of a group of men and women that are very passionate about correcting this issue. And Associate Professor Kate Hoy is one of my mentors here, and she's incredibly successful in her career, but also is someone that's working incredibly hard towards instilling change for women in STEM. So I have two, I guess, good examples of what I've noticed. The first one is the gender inequality issue at the largest brain stimulation conference that we have. So what we noticed was that there are really very few women that are being invited to present at these conferences. In the first conference, which was about 4 years ago now, there was 5% of females that were invited to present. And at the last conference 2 years ago, there was zero females invited to present. So that's actually not gone unnoticed by a lot of people in the community. Yeah, so there's been some statistics done on the gender distribution among authors that have published top-ranking papers in the journal in our field. And we found that 33% of first author or senior author publications were by female authors. So that's completely inconsistent with the number of females that are invited to the conference. And I'm not really sure what else can explain that apart from a gender bias. And the 33% of females that we see that publish these high, top-ranking papers, that's actually consistent with the number of females that we see in neuroscience departments as well. So it's been something that's been published as a letter to the editor to the journal. There's been a few responses to that. So I think that that's really telling, but I think it's really wonderful that we can't really get away with it anymore. We can't get away with not having gender equality or diversity at conferences, for example, and that we'll actually speak out about it. So that's the first thing that comes to mind. The second thing that I've noticed, and brain stimulation is a technical field as well, and so perhaps it's more obvious in this sort of field, but I feel that women and men tend to unintentionally fall into different sort of roles. So women tend to do a lot more administrative and services sort of work, and males tend to fall into the more technical roles. And I think that this contributes to the loss of mid-career female academics, because females tend to be doing the majority of the administrative work to carry forward organizations and teams, and they have less opportunity to actually do research. And I think this is really just an implicit, fundamental gender conditioning issue. And so, in my team, we're very conscious of that, and we're very conscious about not segregating roles by gender. And I think, but I think it's something that I certainly have noticed, and as a more senior researcher.
So do you think the way science is funded in Australia could be one of the reasons that women may struggle in their careers in science?
One of the issues that we have is that a lot of early career researchers get more supported through our funding system, through the National Health and Medical Research Council. And there's a lot of support for senior researchers as well. But there's this massive gap in the middle. And it's less than 10% success rate for the fellowships for the mid-career stage. In fact, the success rate for project grants, which is the main source of project funding, is less than 10% as well, or around 10%. So we've got this relative dearth of mid-career researchers at the moment, and there is a worry that when the senior researchers begin to retire, there might not be enough people to take over at that stage. But having said that, the NHMRC is going through a major overhaul at the moment. There's lots of changes, and they're certainly aware of the issues that we have with funding in general and to do with the mid-career researchers. And so I'm really quite hopeful that that will change in the future, and that the new ways of giving funding would correct these issues.
Could this be driving people overseas, leading to a brain drain?
I'm not sure where we're losing them to. I'm not sure if it's overseas. I certainly think that people are leaving academia at a mid-career stage because there is it's not, even if you get a fellowship, you have 4 years, and then you got to think about getting funding after that, and in some cases you just don't get any, so you have to think of about an alternate career option, whether that's going into teaching or leaving academia altogether. I think, so I'm not sure, but I know for females, we tend to lose females in academia at the mid-career stage. There's a variety of reasons for that, but it makes sense that one of the reasons is the lack of funding available at that career stage.
Okay, so where to now for you? What does the future hold for you in your career?
Well, I really like the path that I'm going on. At the moment, my next step is to establish a unit within the Monash Alfred Psychiatry Research Centre for early intervention for mental illness with brain stimulation treatments. So that's my immediate 2-year plan, or 2 to 5 year plan. Following that, I would like to grow that unit. I would like to head a team to continue to look at optimizing brain stimulation treatments, as well as developing new ones, and really get brain stimulation on the market for intervention for youth mental illness. I imagine my trajectory to be very much an academic one, one where I get to have the opportunity to lead a research program in a lab. But I'm just hoping that will the new funding sort of framework that we have will enable me to continue to do that.
All right. So just before we go, what is your favourite disease to look at?
My favorite disease to look at? Look, I'm very passionate about dealing with in researching depression, and I think depression, because it affects so many people, it's one of the most common mental illnesses, and in young people, 50% of people that will get it will have it before the age of 30. So the earlier you get it, the higher the chance that you will continue to relapse and have subsequent episodes. It is a chronic disease. It affects most people that get it will have it. This is about 70% will continue to have other episodes, and so it's a really far-reaching issue, and it's a very broad issue. And I think when it comes to depression, we have a lot of potential to treat it and to deal with it. I really, psychosis is the other thing that I've spent time working on, and I really am very passionate about working on psychosis. And I have a project that I'm developing on using brain stimulation to treat people that hear voices, so auditory hallucinations. And it's a very, very difficult thing to treat. In fact, most of our medications can, a lot of the time, treat the other symptoms of psychosis or schizophrenia, but the auditory hallucinations tend to be very poorly treated. But psychosis is a really difficult one because there isn't much. I guess as a research community, we're not finding that much that we're doing is very fruitful. It's a really, really tough thing to treat, and all the more we should be spending more time on it. And it's certainly something I do want to place a lot of importance on in my research career. But I guess we're at a stage where they're, seeing the light at the end of the tunnel. The light's very far away, essentially.
Thank you to Dr. Kaur for taking the time to chat, despite several technical hitches. These things are sent to try us. As always, I am eager to talk to women in science, technology, engineering, maths and medicine for this podcast. So if you know of someone who you think might be a good subject, then please let me know by dropping me a line at james@angrybeanie.com. The intro and outro music for this episode is Coco Core by Texas Radiofish and is licensed Creative Commons Attribution. You can find it at dig.ccmixter.org.